Hey there, science fans! Today we're diving into the exciting world of sequences. Imagine a line of dominoes, each one perfectly placed after the other. That's a sequence. It's an ordered list of numbers or things that follow a specific pattern. Sequences are everywhere. Think about your house number or the pages in your favorite book. Those are sequences in action. In math, sequences are like secret codes that help us understand patterns and make predictions. They're used in everything from computer science to music. So, get ready to unlock the magic of sequences. We're going on an adventure of patterns, numbers, and endless possibilities. Let's talk about ascending sequences. Imagine climbing up a ladder, rung by rung. That's like an ascending sequence where each number is bigger than the one before it. For example, 1, 2, 3, 4, 5 is an ascending sequence. Each number goes up by 1. We can also have ascending sequences with bigger jumps like 2, 4, 6, 8, where each number goes up by 2. Ascending sequences show growth, like a plant getting taller or a savings account growing bigger. They're a fun way to see how things increase in a predictable way. Now hold on tight as we go down the slide of descending sequences. These are like riding a roller coaster downhill. Each number gets smaller than the one before it. Imagine counting down from 10, 10, 9, 8, 7. That's a descending sequence. We can also have descending sequences with bigger drops like 20, 15, 10, 5, where each number goes down by 5. Descending sequences show us how things decrease, like the air going out of a balloon or the temperature dropping on a chilly day. They help us understand how things change in a decreasing pattern. Some sequences are like a fun car ride. They have a starting point and a destination. We call these finite sequences. They have a specific number of terms or numbers in them. Think about the days of the week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. That's a finite sequence with 7 terms. It has a beginning and an end. Finite sequences are great for representing things that have a limit, like the number of students in a classroom or the ingredients in your favorite recipe. Section 5. The infinite adventure sequences that never stop. Hold on to your hats because now we're talking about infinite sequences. These sequences are like a rocket ship blasting off into space. They go on forever. Imagine counting all the numbers starting from 1, 1, 2, 3, 4, 5, and never stopping. That's an infinite sequence. It has no end. Infinite sequences are used to represent things that are continuous, like time or the patterns in a fractal. They help us understand concepts that are boundless and ever-expanding. Section 6. Arithmetic adventures. Sequences with a steady beat. Get ready to march to the beat of arithmetic sequences. These sequences are like a steady drumbeat. Each term is found by adding the same number over and over. For example, 2, 4, 6, 8 is an arithmetic sequence because we add 2 to get to the next term. This added number is called the common difference. Arithmetic sequences are used in lots of real-life situations like calculating the distance traveled at a constant speed or figuring out the pattern in a musical scale. Section 7. Geometric journeys. Sequences with a multiplying twist. Now let's zoom into the exciting world of geometric sequences. These sequences are like a magic trick where each term is found by multiplying the previous term by the same number. For example, 2, 4, 8, 16 is a geometric sequence because we multiply each term by 2 to get to the next one. This multiplying number is called the common ratio. Geometric sequences are used to model things that grow or decay rapidly, like the spread of a virus or the interest earned on an investment. Section 8. The Fibonacci Fascination, Nature's Golden Spiral. Get ready to be amazed by the Fibonacci sequence. This mathematical marvel is not just a series of numbers, it's a gateway to understanding the hidden patterns of the universe. This sequence is like a secret code found in nature, art, and even music. From the arrangement of leaves on a stem to the branching of trees, the Fibonacci sequence is everywhere. In this sequence, each number is the sum of the 2 numbers before it. It's a simple yet profound concept that has fascinated mathematicians for centuries. It starts like this: 1, 1, 2, 3, 5, 8. See the pattern? Each step builds on the previous ones, creating a harmonious progression. 1 plus 1 equals 2, a fundamental building block. 1 plus 2 equals 3, adding another layer to the sequence. 2 plus 3 equals 5, and so on. Each number is a step in an endless journey of discovery. The Fibonacci sequence creates a beautiful spiral pattern called the golden spiral, a shape that appears in countless forms in the natural world. We see this spiral in seashells, sunflowers, and even galaxies. It's a universal pattern that connects the smallest forms of life to the vastness of the cosmos. It's a fascinating example of how math and nature are interconnected. The Fibonacci sequence is a bridge between the abstract world of numbers and the tangible beauty of the natural world, revealing the harmony that underlies all creation. Section 9. Series and partial sums. Adding up the fun. This section is all about diving deeper into the world of sequences and understanding how they come together to form something even more fascinating. Let's add a new twist to our sequence adventure with series and partial sums. These concepts might sound complex, but they are actually quite intuitive once you get the hang of them. A series is simply what we get when we add up all the terms in a sequence. Think of it as a way to sum up the journey of numbers, capturing the essence of their progression. For example, for the sequence 1, 2, 3, 4, the series would be 1 plus 2 plus 3 plus 4 equals 10. This simple addition helps us see the cumulative effect of the sequence. It's like combining all the pieces of a puzzle to see the bigger picture. Each number in the sequence is a piece, and the series is the completed puzzle, revealing the full image. Partial sums are like mini-series, where we add up only a certain number of terms in a sequence. They give us a snapshot of the sequence at different stages. For example, the partial sum of the first 3 terms in the sequence 1, 2, 3, 4 would be 1 plus 2 plus 3 equals 6. This helps us understand the sequence in smaller, more manageable chunks. Series and partial sums help us understand the behavior of sequences over time and are used in various fields like finance and physics. They allow us to predict trends, analyze patterns, and solve complex problems by breaking them down into simpler parts. Whether you're a student trying to grasp the basics or a professional applying these concepts in real-world scenarios, understanding series and partial sums is a valuable skill. It opens up a new way of thinking about numbers and their relationships. So let's embrace the challenge and add up the fun as we explore the fascinating world of series and partial sums. With practice and curiosity, you'll find that these mathematical concepts are not just useful, but also incredibly rewarding to learn. Section 10. Unlocking the code formulas and missing numbers. In this section, we will dive deep into the fascinating world of mathematical sequences and the formulas that help us decode them. Now, let's unlock the secret code of sequences using formulas. These formulas are powerful tools that allow us to find specific terms in a sequence without having to list out every single term. Imagine the time and effort saved. Formulas are like special equations that help us find any term in a sequence without having to write out the entire thing. They provide a shortcut to understanding complex patterns and relationships between numbers. For arithmetic sequences, we have a handy formula, n equals a1 plus n minus 1 d. This formula is essential for quickly identifying any term in an arithmetic sequence. Where n is the term we want to find, a1 is the first term, n is the term number, and d is the common difference. The common difference is the amount by which each term increases or decreases. For geometric sequences, we have a different formula, n equals a1 times r to the power of n minus 1. This formula helps us find terms in sequences where each term is multiplied by a constant factor, where r is the common ratio. The common ratio is the factor by which each term is multiplied to get the next term. Understanding this ratio is key to mastering geometric sequences. These formulas are like magic keys that unlock the secrets of sequences, making it easy to find missing terms and predict future patterns. They transform complex problems into manageable steps. So there you have it. With these formulas, you can tackle any sequence problem with confidence and ease. We've explored the amazing world of sequences, from ascending and descending patterns to infinite possibilities and special formulas. Each sequence tells a unique story, and with these tools, you can uncover those stories. Now you're a sequence superstar, ready to discover the magic of patterns and numbers all around you. Keep those sequences flowing and continue to explore the endless possibilities that mathematics offers. The world of numbers is vast and full of wonder, and you are now equipped to navigate it with skill and curiosity.